Hey kids, how's it going? So tonight we're going to discuss, or today, whatever, you're going to talk about displacement of an engine. Okay? What that simply means is this. In the engine, there's going to be multiple cylinders. Let's say this one has 4. Whatevs. They're all the same size, yo. Okay? If Mr. Groom asks you to find the volume of these cylinders, I feel like one would simply do this. You'd go, well, Mr. Groom, so-and-so told me to take pi times the radius squared times the height, and then times the number of cylinders, because obviously if there's 4 of them, they're exactly the same. And I feel like you're exactly right, ma'am, sir. You're totally right. Well done. Awesome job. Cool. Now, it turns out that we talk about the diameter of a cylinder, and when it comes to an engine, we talk about that as being the bore of the engine. Bore is equal to diameter. Okay? And height, which is right here, we can actually refer to as the stroke of the engine. And so this is how we do it in math class. Turns out in a auto shop class, a person should probably do this. It will always be divided by 4 because you're using the diameter instead of the radius. So since the diameter is twice as big and then you square it, you're going to get a factor of 4 right there. And so you need to divide by that 4 out. It's pretty straightforward. So on every engine, we're going to give you what's called the bore and the stroke. So I'm going to give it to you for this engine right here. The bore is 4 inches. Nice. And the stroke we'll say is 3 inches. And we're going to say there's 8 cylinders here. Oh, dude, rock on. Let's do it, yo. So, Mr. Groom, how would I do this? I would simply go displacement equals pi times 4 square divided by 4 times 3 times 8. Hot diggity dang, I don't have a calculator on this computer because my life is just... All right, let's see if Mr. Groom can do it. Now, I am going to do it on my cellular device. I have a cellular phone here, you know. What's a cellular phone, Mr. Groom? Oh, for heaven's sakes. Anyways, so I am simply going to type in 3.14. If I don't have a calculator, so what I want you guys to do for this is just literally use 3.14 for pi. Now, I say do that because it would be nice if we all got the exact same answer. You with me? So we know 3.14159, yada, 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 yada. That's true. However, yeah, it's just going to make everything messy if we do that, I think. And I get, lo and behold, 301.44. Now, this is going to be measured always in inches cubed, or if you prefer, and I do, cubic inches. Nice. Mr. Groom, that's awfully close to a certain number. 301. Well, turns out Ford would round that up and call it 302. But you get the point. And they would round it up and call it 302 because in reality it would be 3.14159, yada, 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 times. And they would actually get 301.6, which would round up to 302. But irregardless, this is what you're going to put. We are going to use 3.14 for our measurements. Therefore, I don't have to worry so much about regrading everything. Does that make sense? I don't want to have to do that. So I will use 3.14 in my calculations. You use 3.14 in your calculations. We should agree on an answer. Cool. Let's do another one, shall we? So Mr. Groom comes along. He sees this, and this one here, it is a, the bore is 4.375. And the stroke is 4.125. These are in inches, yo. And this is a 8-cylinder engine. Rock on, dog. So displacement is equal to pi, so 3.14 times 4.375 Squirt, divide by 4 times 4.125 times 8. And we are done. Let's make it happen. Let's make a deal. Hey, boo-boo. Let's get a picnic basket. Hey, boo-boo. But Yogi... I miss my good calculator. I want my other tablet back. This tablet is no bueno. Oh, it looks like Mr. Groom got 495. 495.837. Mr. Groom is going to round that up to 495.84 in this case. If I'm going to round 2 decimal places, I may tell you just to round to the nearest whole number. So let's call it 496. That makes sense. That's probably what I'll end up doing the test. On the assignment, I'll probably just say round to the nearest whole number. So that would round up to 496, and we'll call it good at that. Nice. Okay, that's hot, man. Let's do another one, shall we? So let's do one that, say, has a bore of 3 1/4 and a stroke of 3. And, 6 cylinders. Sweet. All right. What does that simply mean? It just means that you're finding that this first part, when you do 3.14 times 3.25 squared over 4 times 3, this is for 1 cylinder, friends. And then I simply multiply it by 6 because there's 6 cylinders, obviously. Obviously, Mr. Groom. I get 149, 2, 4, 8, or let's just say that rounds up, or it rounds down to 149 inches cubed, or 149 cubic inches. Goodness sakes alive. Awesome possum. Now, that is how we look at things. That's how we've always looked at car engines in America until pretty much the early 90s, late 80s. In the late 80s, early 90s, wait, Mr. Groom, isn't that about when we started talking about, we started using more metric fasteners then? Yes, exact same time. Wait, don't tell me. Did those suckers start measuring the bore and the stroke differently? Why, they sure did, friend. They started measuring in centimeters and centimeters. Oh, are you kidding me? So our answers are going to be centimeters cubed. Well, kind of. Okay, now, here's the dealio. Okay, it's still going to be the exact same formula. Displacement is equal to 3.14 times the bore square divided by 4 times the stroke times the number of cylinders. It's always going to be the same formula. Don't even worry about it. But notice it's going to be, this is going to be centimeters times centimeters. So centimeters squared times centimeters again. It's going to be centimeters cubed. Now, that's kind of a big deal. Now, if you're playing along at home, here is 1 inch. Turns out that 1 inch is roughly 2.5 centimeters. Roughly. Wait, so you're saying that, like, literally all we have to do is that we can convert between the two? You could, but don't do that. If it's given to you in centimeters, then just freaking leave it in centimeters, brah. And if it's in inches, then just leave it in inches, alright? It isn't going to hurt anything. It just makes your life that much easier. Now, Mr. Groom is going to look up a bore and a stroke from an engine just because he feels like it. Does he have to? No. He just feels like he could make them up, for heaven's sakes. It's totes fine, but he doesn't feel like doing it right now. So it turns out that this one here is pretty interesting. This is a pretty interesting engine that people get excited about. This engine, I kind of like it too. It has a bore of 107.9. No, it's not true, you jackass. 10.795 centimeters. And it has a stroke of 11.099 centimeters. Wait, I feel like if you divided this by about 2.5, you'd get about 4 inches. That's right. Yeah, you get 4 something inches. That's right. You're not wrong. Notice that this one's a little weird, and we're going to talk some more about this in the future. This one's got a longer stroke, a bigger stroke than it does a bore. The ones I've done previous to this have always been the other way around. That's another classification we're going to learn about too. Okay, but here it goes. This height. So 3.14 times 10.795 square divided by 4 times 11.099 times, and this is an 8-cylinder engine, times 8. So how you doing? Clear. 3.14 times, that's 314, you jackwagon. 3.14 times 10.795 times. Oh, look at that now. Holy buckets. That is 100% correct. 8,000? Well, duh. Yeah, brah. Check it out. It makes perfect sense if you think about it. This guy right here, this is going to be roughly 120. Divided by 4 is going to be like 30-something. Times 3 is basically 100. 100 times this is basically 1,100. 1,100 times 8 is going to be 8,000 and something. Well, son of a gun. What do you know? So, yeah, that's a big engine. Now, Mr. Groom, wait a minute. Are you going to tell me there's an engine out there that goes by the 8,122 centimeters cubed? No, in fact, it doesn't. So, in fact, what happens here is this. It turns out, and this is a fact, you should probably jot this down, 1,000 centimeters cubed is equal to 1 liter. You know the 1 liter bottle of pop that you buy at the store, not the 2 liter, the 1 liter, friend. This engine would in essence hold 8.1 liters. So the way this is done, watch carefully, this is very important. It's 1,000. When you divide by 1,000, you're simply going to move the decimal place. 1, 2, 3. And you're going to get 8.1. Okay, we're going to round it off to that. You could put the 2 if that makes you happier. Liters. So this, we would say this is an 8.1, and that's what it rounds off to. That's what Chevy refers to this as, an 8.1 liter engine. Okay. And so they just round it off, and they round it down to there, okay? I don't really care. I will tell you on the test, well, on the thing, what I want you to do. Probably what I'll say is this. Do it, and I'll say something like this. Round to the nearest point, and the nearest 1 decimal place liter. So that'd be an 8.1 liters. Okay? So we can do these all day long. You're like, Mr. Groom, do another one. Would love to do that for you, friend. Let's do a... Sure. Oh, yes. Here's a nice little Q engine. Mr. Groom is not a big fan of this engine, but I seem to work on it a lot, so that's cool. Oh, you loser. Now, I happen to know that is not true. So, interestingly enough, Mr. Groom was like, I'm just going to look it up here on the doohoo here. I'm going to ask the great Googly Moogly. And so, some jackwagon has actually converted it over to inches. In fact, so does this one. This one has it in inches as well, which I find beyond obnoxious. Okay, it's beyond obnoxious. And the reason I find it a little beyond obnoxious is because, in reality, that engine was designed using a metric ruler. I've read quite a bit about this engine, and I've known a lot about it because I've worked on it a lot. And the idea is that that engine was what they call a clean sheet design. Okay, that is, they started over from scratch. And they said, listen, we're going to design this engine. We're going to design it totally. We're going to design it totally but we're going to use metrics when we do it. Bore and stroke and centimeters, and is also an 8-cylinder. Okay, so the idea here is this: it's pi. Wait, pi. Mr. Green, you don't write pi. You said to use. I know what I said. 8.14 times 8.9 squared times 8.9 times 8 What do you notice about this? I feel like in this case, the bore and the stroke are exactly the same. You're like, that's kind of cool. That's kind of, what is up with that? Well, it has a name, and I'm going to tell you what it is here momentarily. Well, this computer's getting hot on my leg. Now, I rounded this just a skosh. Oops, 4,427. Okay? That's cubic centimeters. Okay? So what I said was, when I rounded this, I rounded it a little bit. It wasn't exactly 8.9. I rounded it to 8.9, okay? Don't worry about it. There it is. So when we say this would be cubic centimeters. We're going to say that this, 1, 2, 3, 4.4 liters. Okay? And if I hadn't rounded it so hard, that would have been a Ford 4.6 liter engine. Okay? And so I rounded it a little bit, but that's how life goes. Let's see if I can find another one here. Nope. Ooh, there. Oh, nope. No, don't do that, you jackwagon. You're so dumb. All right, let's do this. Let's do. Nice. Oh, here we go. Oh, that's hot. Nice. Now, it turns out that it has a bore of 8.5 centimeters. And it has a stroke of 7.5 centimeters. And it's a 4-cylinder engine. So, simply, displacement is 3.14 times 8.5 squared divided by 4. Make sure that parentheses is on top, you goober. Times 7.5 times foe. Mr. Groom, isn't it true that this foe and this 4 cancel out? It does. If you didn't know that, if you times it all out, will it work? Yeah, that's how math works, bro. So, Mr. Groom loves math, by the way, if you haven't figured that out yet. I pretty much dig math. It is the bomb, if you will. Ooh, looky there, will ya? 1,701 centimeters cubed, which we then would say, 1, 2, 3, 1.7 liter engine. Okay? It is that easy, my friend. There is not much to that. Now, some things that I will talk about when we classify these things. So if you have an engine, okay, where the bore is greater than the stroke, we call that an over square engine. Okay? That's what we call that. If your bore is less than the stroke, we call that, of course, under square engine. And if the bore is equal to the stroke, we call that a square engine. Nice. Now, a square engine is very, very, very nice to have. Okay, it has very nice characteristics. If you have a very short stroke, that is this top guy here, all things being equal, those things tend to be able to rev a little higher, but that's not 100% true. There's a lot more to it than that. But that does help nicely. If you think about this down here, this is like Mr. Groom with his ginormously long legs. If you've never seen me in person, I have kind of long legs. I'm kind of short from about here up. I have ridiculously long legs. Now, when I walk, it is very hard for me to get my legs moving very fast, okay? Because I cover a lot of ground, but they don't move very fast, okay? And that's the same thing is true when you have super long connecting rods, okay? Or a super long stroke for it has to go up and down and up and down. And so it's got to go a long ways. The idea is this. That piston has to travel a certain distance, and it has a certain amount of time to do it. So at the same RPM, if your crankshaft is spinning the exact same speed, the under square engine is this guy here is going to be traveling a lot faster, which is hard on things, versus the under square engine is going to be traveling it's going to not be hard on things because the piston has to stop speed up super fast and then stop, and then speed up super fast and then stop on the top and the bottom of each of those strokes. And it's very hard to do. Okay, it's very hard on things. And so that big Lincoln motor I showed you in the shop with the it was a flat iron. It had super tiny bores and long strokes. That's how they used to make engines all the time. And then they started making them a little bit more over square, but then we still see these guys here in the middle where the bore is equal to the stroke, and that's a square engine. I guess if you asked me, Mr. If you were designing one, well, first thing I'd ask you maybe is what you want to do with it. But the second thing I'd ask you is, listen, I'm going to build that thing, probably going to build it square. Now, a lot of tractor engines, some semi engines, because those things do not turn a lot of RPMs. The engine does not rev very fast. The crankshaft does not spin very fast. Those tend to like to be a little bit of an under square engine. So today, when we looked outside the classroom, you saw those long connecting rods on the pistons. They were just outside the door. The super long ones, those came out of like a tractor or a semi engine. And because those don't have to turn very fast, they typically have long strokes. And that helps out with kind of low end torque, low end power when they're trying to pull stuff. That's why you want a tractor or a truck to be that way, a tractor or a semi, because they're never going to be turning a lot of RPMs. A drag race engine, an engine that's going to be revving super high, like 9,000, 10,000 RPMs or something ridiculous like that. Yeah, you're going to be a square engine or just slightly over square, because you want to have shorter shorter stroke, so the piston doesn't have to go as fast up and down. Okay, and again, we'll talk more about that later on. What I'm going to ask you about today simply is this. Here is an example of a bore of 10.9 centimeters, nice, and a stroke of I don't know, 9.1 centimeters, and this is a 6-cylinder engine. Okay, the idea here is this is a over square engine because the bore is bigger than that. That's all I want you to say, and then go to solving it. The displacement is equal to 3.14 times 10.9 square over 4 times 9.1 times 6. And if you punch that out, freaking computer is burning my leg. It's not optimal, friends. The things I do for you people, it's only because I care about the children. It's for the children, Mr. Groom. Do it for the children. This thing has a displacement of 5,092 centimeters cubed. And friends, we are going to go 1, 2, 3. 5.092, if he makes you happy, liters, my friend. And that is that. Now, you're like, Mr. Groom, this is not hard. No, it's not. It's actually almost, it's almost fun. Dare I say it? Yes, there I said it. There I said it. Now, one more. I'm going to do one more here, and I just want to see if you recognize something like this. Nice. This is hot. Now, Mr. Groom, this particular engine has a bore of 7.9. Wow, looks like the last one, kinda. Kinda. Ooh, it's also, what is this one here? This one is also over square. Nice, centimeters. Cool. Now wait for it though. 1 cylinder. Wait, shut up. What? Oh, that's weird, Mr. Groom. Let's do it, yo. 3.14. 7.9 squared divided by 4 times 5.1 times 1. Do you have to times by 1? No, dude, it's just a formula. I'm just doing it because some people don't get it if you don't show every step. And I just care, so I'm going to show every step. So it's I. What? 249.85 centimeters cubed. Why, Mr. Groom, that looks an awful like 250 centimeters cubed. I would not argue with you. Wait a minute now. 1, 2, 3. 0.25 liters. That does not sound very impressive, friends. You have a 0.25 liter engine. That just sounds Well, it sounds stupid and ridiculous. So, turns out this is a Honda 250, the CRF 250R engine dirt bike. Wait a minute, Mr. Groom. They don't call those 250 0.25 liters. They call them 250 cc's. That's right, baby. 250 cc's. Wait a minute. The cc's stand for cubic centimeters? You know it, pal. So why, Mr. Groom, do they not refer to it as an 8100 cc engine in that big truck? I don't know, because 8.1 liters sounds cooler. That's why, I guess. Why is a 350 Chevy a 5.7 liter engine? I don't know. I guess because when they switched over to giving them when they went to fuel injection, they switched over to the metric designation. But 5700 cc's sounds ridiculous, so we'll just call it 5.7 cc's. Personally, I think 350 cubic inches sounds better. But when you get down to a very small size like this fella here, 0.25 liters sounds pretty lame. It sounds ridiculous, as a matter of fact. And so down there, we would refer to that as cubic centimeters. Okay? Nice. One more thing to do today, and I was going to introduce this today. We talked in class the last 2 days about how we classify engines. And so we talked about where their valves live, whether they're overhead valves or flatheads. That's true. We're going to talk tonight a little bit. We just did about over square, under square, or square engines based on their bore and their stroke. And then the last thing I want to mention is this. If when you look at the block of an engine, the crankshaft sits here, and the cylinders sit like this and like this, this is a V-style engine. Okay? Because you can see, that's a V, isn't it? Ooh, that's cute. Mr. Groom, what do we see these in? Well, typically V6s and V8s. Okay, Dodge and Ford both had a V10. There are other different engines like Mr. Groom. Isn't it true that Cummins made a V12 and a V16? Yes, they did. Well, aren't those kind of weird? They are. The V12 they called the Buzzin' Dozen, by the way. I thought that was a cool nickname for that engine. All right, you should giggle it. Turn the speakers up loud on the YouTubes when you hear the Buzzin' Dozen go. That thing is nice and loud. Once in a while, you'll see a V4 on a motorcycle. It's rare, if ever, you'd see one in a car. Just saying. Obviously, you can't have a V5. That would be lunacy. You'd have 3 on one side and 2 on the other. So to be a V-shaped engine, you'd have to have, and I mean have to have, an even number of cylinders, clearly. Okay? So V's are very traditional kinds of engines. Okay? You will also see the ones like I drew in class today, and I'm just going to kind of draw it again, where they sit in a row, like so. 1, 2, 3, 4. I don't know how many I put in there. This is referred to as an inline engine, or sometimes a straight engine, for obvious reasons, because it's freaking straight, obviously. Now, typically, we'd refer to this as an inline 4 or an inline 6. Chevy had an inline 5 recently. Like Volvo's made 5 cylinders before. That's weird. Back in the day, back in the 30s or 40s, Packard made a Packard, and I think Buick also made inline 8s, straight 8s. Now, listen, when they're inline 6s and inline 8s, we usually refer to them as straight 6s and straight 8s. But anything else, typically you just say inline. Now, the newer generation, you younger folks like to use inline, but whatever. Okay. Oh, as a matter of fact, that truck that's in the garage in the shop right now, that white one that's the diesel, it is a 5-cylinder diesel in an inline configuration. Now that I think about it, I was going to mention that. Okay. These are the big ones that we see. It would be one or the other of these. We see a lot of 4-cylinder inlines. And we see a lot of V6s and a lot of V8s. Okay, that's just what we see a lot of. We don't see a lot of straight 6s anymore. Okay, they kind of went out of vogue a little bit. It's unfortunate. They're a cool engine. Problem with them is they're long. Okay, that's the only big problem with them. Everything else about them is really awesome. Okay, but you don't see a ton of them anymore. Okay? And then here's one that everybody, well, all you younger people kind of like this one. I really don't care for it. I mean, I don't hate it. I don't hate it, but it's not my favorite engine, man. It's just whatever. This Those are your heads here and here. Here are your cylinders here and here. Wait, what? Nuh-uh. See, your pistons are sideways? That's right. What? Shut up. No, I'm not going to shut up, bro. And then here's your crankshaft in the middle. We call this a horizontally opposed. And again, these have to come in groups of 2. So typically a 4-cylinder or a 6-cylinder, that's about what you'll see. Subarus use these a ton. They refer to them sometimes as boxer engines. Porsche uses them. VW uses them on the old bug cars. So yeah, they've been around for a long time. Nothing wrong with them. They're just a different style. Okay. And again, it's a classification. We will primarily see these two, and then occasionally we'll see these guys like on a Subaru later on. Okay. All right, the only difference, of course, friends, is how their pistons do move. Their pistons here are moving straight up and down, 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 straight up and down. This one's kind of going at an angle, back and forth. This guy here just goes side to 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 side. Okay. This one, the reason that this one's kind of cool is because in the Subaru, for instance, you notice how if you look at them, and if you never pay attention, look at one next time you see one, the hood is really low profile to the ground. The reason they can do that is because this thing is a very small, top to bottom, height-wise engine. This is a very short engine, top to bottom. And so therefore, you can put the hood down over the top of it, and that hood can be really close to the ground, just because of the fact of how this engine is shaped. Okay, clearly, and it's kind of a neat thing in that regard. Clearly, this guy is going to be not as tall as the straight 6. Why? Because these things can go tipped off to the side. If you stood them straight up in the air, they're going to be taller. Okay, I didn't draw heads on these guys because there's heads on them as well, and there's a head on this guy as well. Okay, and so the straight 6s kind of went out of vogue because they were so long. Okay, as I say, as a gas engine, they're so long. All right, they stand up pretty tall, so it's kind of hard to get them in a car. In a pickup, they just didn't make as much horsepower. They didn't try to. They could have made a bigger one and a better one. They could have done a lot more with them, but they didn't. It's kind of went out of vogue. Everyone went to V8s and stuff. So just be aware of that in V6s too. So just be aware of that. You'll see that they don't show up as much. Okay. Diesels, however, you see a lot of diesels that are still straight 6s. Okay, so 6, 7, any of the Cumminses, those are straight 6s. So we'll give you some looks at them when we go around the shop, and from time to time I'll say, oh, what is this one here? Okay, cool. So just be aware of that. It's fairly common to see them in semis, tractors, diesel trucks. It's very common to see a straight 6 because it's a diesel engine. Okay, and am I really concerned about low profile? A hood? No, it's a big old truck, friend. Am I concerned about anything else in that regard, packaging wise? Nope, no, because it's a big old truck. Okay, so I want maybe the better design deal. Okay, so on the homework today, you're going to be doing some identifying. I don't think you're going to be doing any identifying. I'm going to come back to the engine bit later. You're going to identify is this particular engine over square or under square, okay, or square, and then also finding the displacement of the engine. Okay, again, go back, look at the formula. I wrote it down right here. Look at this formula. This is what it's all about. That's not the hokey pokey. That is what it's all about right there. Okay? All right. Peace out, homies.